Today on Education Forum, paleontology, oh, the places you'll go. From the studio, high atop Jordan Hall in the College of Education and Health Professions at Columbus State University in Columbus, Georgia, this is Education Forum with your hosts Jeff Conklin and Greg Blaylock. Welcome to Education Forum. I'm Jeff Conklin, here with my co-host Greg Blaylock. Many believe that a science education is an important part of university studies. And today we're going to talk further about that with our guest today. Our guest today on Education Forum is a professor of geology, but basically in paleontology, Dr. DavidSchwinner. Welcome, David.
Well, thanks. Appreciate it.
Glad to have you on the show. To start out, I'd like you to tell us a little bit of how you got here at Columbus State University.
Well, honestly, a little coincidence. There was a job offered in paleontology. One thing I learned is that Columbus is in a funny place geologically. We're right on the boundary of two areas.
Okay.
We're on what's called the coastal plain and the Piedmont. And the coastal plain is the deposits laid down during the dinosaur age and younger.
Okay.
And interesting thing, no one had ever really looked in Georgia at the coastal plain. So it's, amazingly enough, down here in the southeast is open territory that's never been studied.
That's
research.
great.
You'll think that Montana is the great, or the Gobi Desert, but they've been crawled over by paleontologists.
Oh, sure.
And this place has almost never been touched.
Wow.
So initially when I came here, it was to teach, and just poking around, it was obvious that there was all kinds of stuff. We started finding bones and teeth within months after being down here. And we as students, amateurs, and myself. And so basically this place has turned into a kind of a gold mine of interesting new fossils.
And you were telling us you've been here
34 years.
34 years.
Yeah.
And counting.
And counting.
So,
That's right.
So in poking around, what are some of the significant things you've found as you look back over the last 34 years?
Almost, you could say, firsts of a whole bunch of common kinds of creatures. We found the first dinosaurs in Georgia and East Alabama.
Okay.
And we, again, as students, amateurs, myself, we found the first falling reptiles, what people call pterodactyls. We found, I reported on, I didn't discover it, I worked with some amateurs who found a phenomenal giant coelacanth fish. If you're familiar with that.
No.
Well, coelacanths are living fossils. They're things that supposedly went extinct back in the dinosaur age.
Okay.
Well, we found one that's 15 feet long, at least the skull of it, and now we're finding specimens all over the world. And it was the last one known as a fossil before the living one appears. So
is that right?
A little complicated, but it's a really important subject.
It sounds like it, yeah.
Obviously, we found mosasaurs, plesiosaurs. I've described over 30 species of fish, including some pretty new sharks. We found mastodon bones.
Right here in this area.
Well, here within 30-mile radius.
That's
south,
close.
Wow.
All Columbus and south.
Yeah, that's really close.
Columbus and north, as we say in New York, forget about it. But Columbus south, the work area that I've been ranging is through Stewart, Marion, Lee, Russell counties down to Barber, Bullitt counties.
Sure.
That's sort of our area.
Okay.
Chattahoochee County too. Fort Benning's full of good stuff.
Oh, is it really?
Yeah.
Well, it's huge. So
yeah, it's huge, and it happens to be right smack on one particular bed of fossils. So essentially, fossils are everywhere here.
Interesting.
And if you just look, they're there.
You mentioned a couple times that a lot of your work involves students and other amateurs. Tell us a little bit about what a student experience is when you're going out.
Well, it starts, we take the students out on field trips. All of us in geology take our students with us routinely.
Okay.
So our students get a lot of field experience. When I go out collecting, I almost always go with students. And in fact, a lot of the discoveries have been made in classes. I've had students who, in class trips, have discovered firsts of a kind.
Wow.
And then usually our majors take over and get out in the field too. So we kind of combine my own research with student research, and Also, there are a lot of interested amateurs in the region, some of who become students. And there are people who have collections of fossils that have been sitting in Granny's attic since the last century.
Is that right?
So once I let it be known that there was a professional paleontologist in the region who'd be glad to look at anything, lots of interesting stuff came along.
I see.
In fact, that's probably the secret to research success here, is just listen to people. You go through tons of junk. I mean, I can't tell you how many phony dinosaur eggs, I can tell you stories about that, and meteorites that aren't, you know. And
sure.
One lady asked me to see the tiny footprints in her backyard. There were little things about that big that she thought were human footprints. Anyway, and all kinds of fun stuff. But amongst the chaff is some grain.
Okay.
And over the years, students, amateurs have uncovered just a whole bestiary of creatures, mostly from what we call the Cretaceous period, which is the end of the dinosaur age. It's the one after Jurassic, which everyone knows.
Of course.
Sure. Yeah. Okay. So you spend a great deal of your time just literally looking at pieces that people will bring you, or that you found out in the field.
Yeah.
You're in your lab looking at them with students and evaluating what they are.
In my lab, I have the best and one of the only collections of Cretaceous fossils in Georgia.
Is that right?
As far as I know, every dinosaur fossil known in Georgia is in my lab. It's not a lot, it's 2 drawers full.
But
plus a cabinet full of big bones.
But no one else was looking before.
But no one else was looking. It's really, a lot of it's heuristic. You search and you find. It's one of the aspects of science philosophy is the concept of positivism, that information can be gathered.
Okay.
So if you assume a positive assumption that there's information out there, if you look for it, there it is.
Okay. Okay. Now you say you take students out on every one of these.
Not everyone, but everyone I can. Yeah.
Okay. Okay.
Once in a while, I get a bug to go out myself and go, without having to answer a question.
Right.
But usually, in fact, for safety, because some of our field sites are not easy to get to.
To get at.
My best site is through the woods, down a creek, around maybe about a mile off road, and among other things, I've had bullets fired over my head by people randomly shooting in the woods. Not at me, but it's not. As a matter of safety, it's good to have people with you.
Oh yeah.
But it's I try to get students out every time I possibly can, and at least 3-4 times a year.
Okay. Okay. Now, do you ever go other places than just Riesling, or don't you need to?
No. I've got a whole set of separate research areas in Northwest Georgia.
Okay.
And here's the basic thing. One of the reasons Georgia was sort of terra incognita is because no one ever lived here and worked locally. But also, if you just stay local, you don't know what you have.
Sure.
So you have to go somewhere else and see, okay, here's my stuff, what does it mean? So I go to places where there's other stuff known like it. So I go on field trips to places, really remote places like Kansas, Montana, New Mexico. One of the areas that's best for me to do research in is West Texas, because we have almost the same fossils as Big Bend Park.
Okay.
So I've gone 3 summers to Big Bend for research areas, research. And
do you take students for that, or just
that? I haven't. That's been on professional conference trips, and I had a research grant from National Geographic to do some work, so that was a limited thing. I would like to take people to West Texas, but it's a hellaciously long trip with nothing in between.
That's for sure.
From here to
big area.
From here to Big Bend's a long nothing.
Yeah.
And I'm not sure how many students and me have the patience for 2 days, 2 days in a van, seeing nothing but sagebrush and houses.
The flatlands.
Yeah, the
yes,
flatlands.
indeed.
But that's in the back of my mind is an idea of doing a week field trip to Big Bend. So we have to correlate our stuff here in Georgia with the stuff that's been described elsewhere.
Okay.
And I've been tying the stuff cross-continent for years.
Okay.
There's no other reason I can think of to go out to western Kansas.
Right.
No, probably not.
It's got great fossils, but
but there's not much else.
There's no barbecue.
Why did you choose paleontology?
Well, lots of little boys are interested. I'm sorry, that's chauvinist. Little boys, little girls are interested in things. I grew up in Manhattan, Upper West Side of Manhattan until I was 8. And the American Museum of Natural History was just down the block.
Okay.
And I knew every dinosaur when I was 4.
Is that right?
Little boys and dinosaurs.
Oh, absolutely.
Now, of course,
and that hasn't changed.
Right.
Yeah.
And so I always loved. Everyone loves dinosaurs.
Sure. Yeah.
And I was always curious, just really, as a New York City kid, I would love nature, and of course I was frustrated.
Oh,
Yeah,
sure.
absolutely.
And I used to turn over the rocks in Central Park to see what was underneath them. So it's a natural extension of curiosity.
Okay.
Interesting.
Okay.
Interesting.
Yeah, and it actually, it's really the most fun profession I can imagine.
Right.
The way you know this is because there are thousands of amateurs dying to go work. I can't tell you how many emails and letters I get, people asking me to take them to the field.
Take me with you. I want to do
and the
that.
amateurs are dying to work. You know, it's like any profession where amateurs and non-professionals want to work with you for free, you know it's a good field.
That's a pretty good deal.
Yeah, it is.
Yeah.
Makes it a fun
Unfortunately,
field,
it
too.
also makes it a field that's hard to get employment in because people think it's a hobby, and it's difficult it's a difficult profession career by itself. So most of us in paleontology also do something else to earn job title, like my title's geologist.
Geology, yeah.
And I did environmental geology consulting, and I did other things for years as an aside, and I teach other fields of geology too. So all of we paleontologists are geologists / paleontologists or biologists / paleontologists.
Okay.
And many paleontologists are actually in veterinary schools and medical schools.
Is that right?
Lots of my colleagues,
Yeah.
about a third of my colleagues at the meetings turn out to be teaching in med schools.
How come?
Interesting.
Anatomy, we're teaching animal.
okay.
You know the bones of a living thing, you know the bones of a fossil thing.
Gotcha. Okay.
A paleontologist is half geologist, half biologist.
Okay.
So we're trained in both fields.
Sure.
And you have to know a little chemistry too.
So why is it we should care as a society about paleontology and the kind of work that you do?
Okay, well here's a couple of reasons. Number one, if you don't know the past, it may be hard to tell what's possible. For example,
Okay.
one of the hottest fields right now, the most grantable field in paleontology, is called paleoclimatology.
Okay.
Now, for example, you hear things about climate change. A question is, from what? How long has our climate, as we know now, been stable?
Right.
What was it in the past? Well,
Okay.
the most important clues come from paleontology. What animal? For example, if I go to parts of New York State and look at ancient deposits, I can discover things like tupelo trees and cypress and warm weather trees, indicating warmer past climate.
Had to have been warmer before.
And
yeah.
so forth.
Okay.
So on. If I look at the kinds of animals that are found in different places in the past, we can tell what climates were prevailing.
Okay.
So people always think the dinosaur age was warm and lush. How do they know?
Yeah. How would you know?
Well, paleontology.
Yeah.
There are chemical ways to know too, but paleontology gives us a lot of information about the past. Knowing your future is part of knowing your past. So that's important. In fact,
Oh, yeah.
I had a grad student who did a master's thesis, a very good one, on the climate here during the dinosaur age, using some of the data we collected.
Is that right?
And it was
That works
quite a
well.
good study, right?
Yeah.
So
Turns
tell me a
out-
little bit
turns
about
out-
that.
Turns out it was actually not much warmer than it is now.
Oh, is that
The
right?
Really?
The Gulf Coast water was about the same temperature. The plants were a little more tropical, but not much more.
Not too much.
Meaning we're close to the Cretaceous maximum temperature.
Okay.
Doesn't mean the world history max, but we're getting pretty warm. So that's one absolutely critical modern application of this field.
I believe that.
And of course, another thing, the dreaded E word, evolution.
Of course.
How can you tell? The database of evolution is largely paleontology. I mean, we have transition fossils. We have the record of this turning into this over time.
You can see that.
It's,
Yes.
yeah, it's the actual. So it's just simply the database of evolutionary history. There's also now a molecular database based on DNA, but that's more inferential. The actual hard bones don't lie.
Really tell you the
Yeah,
story.
They tell you the story. So
Okay,
there's another
okay.
thing. It's our evolutionary database. Also, it's incredibly interesting. And just like art, music appeal to the aesthetic. It's a very aesthetic science to hold the bones of something that died 20 million years ago, 50 million years ago, to hold a whole fish that died right there on the shores of Fort Benning.
Wow.
That kind of thing.
Wow.
That's
Yeah.
really exciting.
Yeah. That is.
I bet
yeah.
it is.
And it's a little like the same thing. You know how many people collect Indian artifacts, whether they should or not, because
Right.
there's debate about that. But the fascination of holding up an arrowhead someone made 10,000 years ago, well, we're doing that times 5 or 6 decimal places.
Oh yeah.
Sure.
You sure
So,
are.
it's a very, very satisfying field, very exciting.
I can see it's exciting.
And,
yeah.
yeah. I have lots of people come to my lab just looking, oh,
Can I come see?
yeah.
Yeah.
Can I
yeah.
hold a dinosaur bone?
So what are the tools of your trade?
Actually, it's kind of interesting. It's a very cheap science. It can be very cheap. We can have fancy stuff. I've got people with fluoroscopes and devices where they can watch living animals moving and watch their bones in labs. The basic tools consist of a hand lens. I have one on my keychain, a rock hammer,
just
and
in case.
One of my colleagues is a fairly famous guy named Jack Horner. He was Dr. Grant. He's a prototype of that. He said the greatest invention in the 20th century in paleontology was the Ziploc.
So you can bring them back.
Just
huh?
a good bag to
Just
bring
to
up
get
stuff
your
back.
sample.
Okay.
Really.
Okay.
All you really need is a hammer, and even that's optional. He uses ice picks, for example.
Is that
Sure.
right?
Like
Yeah.
pry little teeth out.
That way you don't do the damage.
Tiny tools for digging up stuff out of the ground. Lenses and bags, basic tools. Then you add stuff. Obviously, data nowadays a GPS to locate your stuff.
Oh, sure. And so you come back, yeah.
Probably the most important thing, which no one takes seriously, is a notebook, because a fossil found out of context without data becomes an object. It's
Right.
a found object. It has no science to it.
Okay.
I see.
So
Okay.
if someone brings me a fossil and says, "Here it is.
I've got
What does it
these."
mean? I got this."
Where'd you get
Where'd you
this?
get it?
Yeah.
Well, Daddy found. It's
There
cute.
you
It may
go.
be cute, but it's not. It's
Yeah,
not
where'd it come
paleontology,
from,
right?
really,
Doesn't
yeah.
mean the word we use is provenance, and you must record the provenance. You have to mark the fossil data. You know.
Oh, sure.
So, notebook, field lens, hammer, minimal digging tools, basic equipment. That's what's in my truck all the time. Then if you want to get fancy, we have power jackhammers. I have a power rock saw, one of those old cut-off saws. If you got to cut something out of the rock, then you get other stuff.
What do you cut out of the rock?
Well, sometimes you have a specimen that's in rock that you can't, if you break the specimen out, you're going to break, if you try to get the rock out, you can destroy the specimen.
Okay.
So one specimen I had to saw out of the bedrock, knock it out.
Okay.
Sometimes we use plaster to cover it, keep it field jacketed. You may have seen that. You basically cover the specimen in plaster, cut around to
Right.
take it out, then
Yes.
remove the plaster.
Ah, so you don't.
Sometimes you have to do
Gotcha.
that.
Okay.
That's special cases. You know. Not a lot more. You know, I've got people who work with buckets as their main tool. They'll shovel up sediment, bring it to the lab, sieve it.
Go through.
We have sieves, of course.
Okay.
But the equipment's very cheap.
It sounds like it.
And that's frankly one reason I was able to start here in the early days of Columbus College, because I didn't need a lot of money.
Right, to set up.
Right.
That's right. You got to set up your lab and
most
go.
Most of my grant requests have been for travel funds. Just get me
Oh,
out
sure.
here.
So you can get to
Yeah,
Kansas,
very
or
little,
Texas.
yeah.
Yeah.
Now, also, then when you get to higher levels of work, a really good microscope is important, special kind
I would
of
imagine.
Okay.
I've got a pretty nice lab microscope that took a couple of years to get. A high-power microscope with camera ability, photographic abilities helps. I'm working on a new piece of equipment that cleans off the fossils nicely with a blast of beads, glass or
really?
plastic beads, which
Okay.
we're just putting the parts together for that now. Then you can get higher tech. Then,
Sure.
then you have X-ray diffraction machines at the, in a $250,000 range, and you
Right.
can go. What I've been doing whenever, and of course an electron microscope would be
Yeah,
wonderful.
an SEM sitting in the lab
Right.
would be nice. Huh?
But what I've done is when I need SEM time or XRD or one of the fancy equipments, I sweet talk a friend at another university.
That has one. So yeah.
Get some
okay.
time.
And I cooperate with them.
Sure.
I collaborate with a lot of people.
Sure.
Secret I learned to getting real research done in the early days is collaborate with a famous colleague.
Is that right?
So
okay,
I
sure.
pick colleagues in Berkeley or Duke or other places, and I co-author with them.
Okay.
Use their equipment,
Sure.
and we share the work. And,
Help get you established initially, and then away you
right.
go.
And that's the work.
Gotcha.
And now it's actually kind of funny. It's turned around after all these years, and now people are doing
I
with
would
me.
bet.
because
I
of
would
some of the
bet.
stuff you got
Sure.
here.
It's the funniest thing.
Well,
You got in there when people want
People
you
come to you.
sign your name onto it.
Right, right. Well, thinking about the early days, I'm curious, when you first came here,
Yeah.
you said it was it was an open field here. As a scientist in this area, how do you decide where to go and start digging?
Okay. How do you find fossils?
Yeah, how do you-
Right.
It's hard to say there's a look to rock that contains fossils. First of all, if you drive down a road and you start seeing irregular specks, there's a reason for it. Basic principle: everything is where it is for a reason.
Okay.
Nothing is
not random.
Nothing's random.
Okay.
So if a well, first of all, we know what kind of rock has fossils. It's always sedimentary rock.
All right.
And everyone knows in geology that the whole coastal plain is sedimentary rock. So everywhere from Columbus south to the ocean is sedimentary rock.
okay.
So you start with that assumption. Drive down a road and kind of glance around. We call it windshield geology, and you start seeing something that looks a pattern in the rock it's in your mind. So you stop, dig a little on the roadside, and look. That's
Okay.
Stop and poke, basically.
Okay.
So the early days of exploration were driving roads, following construction crews, and walking creeks, which is a real secret.
Okay.
Some of my best finds have been in creeks, probably the best finds in creeks. We found a fantastic chunk of crocodilian jaw about that long on the Chattahoochee River.
Is that right?
Right on the banks.
Wow.
Guy riding up on a bass boat said, hey, I saw something. You want to come look? So I went down his boat, and we pulled over, and there it was.
There it was.
There it was.
And you recognized it.
Oh, yeah,
I mean,
yeah.
well, there's something. Right.
That's the training. I mean, you
sure.
see You get a sort of a mind shape recognition.
Right.
Okay.
You know, I remember back at my undergraduate days at New Mexico Tech, buddies of mine who were geologists or in the geology program, and I remember it was really frustrating sometimes going with them because we'd go on a road trip somewhere and they were doing exactly what you just described. It just brought it all back. The sort of windshield geology were there, and they would stop and they'd go out and they'd pull out their hammer, and we'd be looking at them like, what are you doing? And they're like very jazzed about what they're looking at and thinking about. And
I'll give you an analogy. There's a certain time in geological history called the Triassic period where we have very little rock in the east that's not much known.
Okay.
And very important things were happening then. Okay. Well, one day a Smithsonian Institution, U.S. National Museum researcher, paleontologist, was stuck on the Beltway in traffic. So he pulled off the side of the road and started digging around. He discovered a trove of fossils no one had ever seen.
Is that right?
Just because he was too bored. He got bored sitting in traffic.
Traffic's not necessarily a bad thing.
No, it doesn't sound like it.
That pull off the road, look at the stuff is really the essence of how a lot of paleontology gets done.
Wow.
That's interesting.
Yeah.
Well, I got to stop you a second because we're going to have to take a break. I'd just like to remind you that you're watching Education Forum, and I'm Jeff Conklin. Hi, we're back at Education Forum. I'm Jeff Conklin. Today with our guest, Dr. DavidSchwinner, who's a paleontologist who's here at Columbus State University. Now, before we went to the break, we were talking about the field and some of the neat stuff he was doing, but I wanted to have him talk a little bit about his past, his history, how he had worked for Jacques Cousteau.
Yeah, that was actually my first real job after grad school.
Okay.
And I got the job by pure coincidence. One of my when I was a grad student, one of my students, I was TA, was a marine sciences major, and he heard that Cousteau's people in New York were looking for a marine geologist, which I was not. But I'm a good reader. So I spent 5 days cramming everything on oceanography and marine geology that I could.
Is that right?
Went in for the job interview, got the job.
Wow, so you faked it into the job.
Yeah, and so I spent about 1.5 years in New York City and a little bit in California ghostwriting for him. We were doing a series of trade books.
Okay.
I don't know if they're still around. I've got copies of them. Basically, it was called The Ocean World of Jacques Cousteau, and I was Jacques Cousteau.
Oh, interesting.
And so he didn't write his own stuff?
Well, in that, I'm not going to speak for his whole career, but in that phase, everything, we ghost wrote that.
Okay.
There was a team of writers. We were listed as senior editors.
Okay.
So he'd have an idea.
They left the authorship ambiguous. Yeah.
Okay.
The books it was like a trade encyclopedia of oceanography. And actually, he came in about once a month. We'd schmooze in the office. We'd meet together. We'd
So
look
you
up
knew
stuff.
Jacques and
Yeah. In fact, he fell asleep at my desk several times. You know, we're friends for about a year.
Is that right?
Well, I'm sure you had friends everywhere, but
Right,
no,
right.
very, very casual sort of place we went out. I also learned an interesting anecdote. Extreme fame is not great.
No?
Like, when we had office dinners that were quite wonderful, some of them very expensive, and Cousteau paid, of course. And that was great. We'd go to very upscale New York restaurants. But one evening we were working late, and we decided to just go out to a beef and ale on the corner, steak and ale or something on the corner, and we had to leave because the people wouldn't leave us alone.
Mobbed.
Oh, is that right?
And they all wanted signatures,
yeah.
they all came up, want to talk. And of course, he can't say, leave me alone, you know.
Right,
Of course not.
So we just smiled and left. And I realized this is you don't want. Even in New York City, super fame leads to no privacy.
I believe that.
Yeah.
Everybody thinks it's so cool.
It was an interesting insight. But anyhow, we were fine.
And that helped your career.
Oh, of course.
Okay.
You know, that parlayed into the next job as an environmental geologist working because the company was impressed and they had new clients who were impressed with someone who'd been with Cousteau, so they hired me, even though I had no real background in the field, but I learned as I went along.
You were there.
And so I worked on a number of environmental projects, including the Alaska pipeline. And we were doing the environmental impact, the monitoring of it, really.
Which was a big part of that.
That was
That's
the first.
what delayed it so much.
That was the first over $10 billion project in the world at the time. And it still works, by the way, in case. You know,
It's still working.
We didn't do anything that fell apart.
No, not yet, no.
And that parlayed into I started doing independent geology consulting for a while. And then after a couple of years, after my degree, about 5, I thought, I'm a paleontologist. I'm not really doing paleontology.
You really weren't, no.
So I took the job at Columbus College in paleontology.
Okay. Now,
that's it.
How many majors are there in your field? I mean,
yeah. Well, in our school, we're actually booming right now. We have, I think on paper, we have probably close to 70 people, students in the Department of Earth and Space Science, of whom perhaps 45 are geology majors. The others are in other parts of Earth and Space Science. That's a pretty healthy enrollment since we're a pretty small department.
Yeah.
And advertisement, it plugs the fact that geology is a very hot field right now.
Why is it a hot field right now?
Well, what do geologists do? We find energy, we work with climate, we work with water. What are some of the biggest societal needs?
Right there.
I mean, right there.
Yes, sir.
We've got the future nailed. The geosciences are the famous saying, if you can't grow it, you have to find it by a geologist.
Makes sense.
Geologists, you know, we're the probably under-recognized but most important suppliers of natural resources.
So you're seeing the uptick of students coming in and wanting to major in geology.
It's amazing to me how the students learn what's profitable, where the career options are before we do.
Is that right?
And because you know, they hear, you know, so-and-so got a degree and got a job, and our students do very well.
Oh yeah. I was going to ask, how are they doing?
They're doing very well in terms of employment, and the future is very, very good. I mean, it's not a short-term bubble. It's got to be the long-term future.
I believe that. Yeah.
So, you know, it's all good.
Do you see many students changing their major once they sort of take a geology class?
Absolutely. It's incredible. Yes. In fact, all of our introductory classes recruit majors because some of them just see how interesting it is. Even just basic physical geology. If you've got a mind toward natural things, if you like outdoors, it's a perfect fit.
It plays right into it.
Yeah. And then they discovered there's actually a career in this. And we talk a little bit, and that's how we get new majors. And I've never met someone who regretted their decision to be a geology major. Now, I will say, for those out there, it's a tough major.
What do you mean?
You have to have a basic background in all the sciences.
So you have to have the chemistry.
You have to have, and physics. And math.
A lot of people would shy away there. Yeah.
So if you're a student who likes at least a medium level of chemistry, at least a basic year's course, 2-semester course in physics, up to at least introductory calculus. The geology part actually is not that hard if you have those backgrounds.
Right, but you got to have the solid math, science background.
And you really do.
And paleontology, of course, requires a biology background. So the students who are interested in paleontology, I urge
really
them
have to get out there and
take zoology and basic biology too. So it's a tough major because it really is an all-science major. It's a very broad field. And geology, by the way, ranges from one extreme end like mine, which is biological geology, to very physical chemical geology. People who work in mineralogy and geochemistry. And there's all ranges of geology in between. So it's one of the broadest fields. Well, it's the whole Earth.
Yes, it is.
You have to think about it. And there's actually oxymoronic terms like lunar geology, which actually doesn't make sense because geology is the study of the Earth. So
it wouldn't
moon
be
study
geology.
of the Earth. So it's an oxymoron, but we all use it. And there's planetary geology. People with an astronomical bent can start in geology. Climatology is becoming an important sub-branch.
Oh, I believe
because of the interest in climate change.
That's right.
So it's the whole physical world, even universe, is really almost within the purview. And we're all in one department now. Also, we have an anthropology program in geology, not a major yet, but I teach one course in human evolution. And we have an archaeologist, Dr. Church. So archaeology is now within our umbrage of earth sciences because it is fundamental.
Which makes sense.
So that would be a separate major then? With the
we haven't developed a major. We're hoping to, but right now we have a minor in it. In fact, that was my undergraduate minor in anthropology. Because I was
kind of what got you to it.
Early back I was thinking, I kind of like to go to Africa and dig up old bones, but that was a little bit improbable.
Right, but it would get you into it.
But these are all related fields, and they're good for people who both want to have a career but also want to work outdoors
what you have to do,
or work with outdoor materials. And some geologists are laboratory people too. But most geologists want to be outdoors, collect stuff, get out,
crawling around,
and it's a dirty field. You don't wear a lot of jackets.
No, absolutely.
In fact, the first geology conference I went to in Washington when I was a grad student, I was so impressed there were people wearing suits and wore field boots.
I
thought that's cool. That's cool. I like this. A lot of Westerners
Well, and that would fit.
Yeah, they just came out of the field, but they throw in their jackets and came to the
look
meeting.
good, so yeah.
I thought this is cool. You know, I like this.
New projects, current projects you're working on. What do you got?
Okay, well, actually, I've got a big project. Long story, everything's a long story. I just finished a project where I was the outside advisor to a student at the University of Paris who was revising some of my earlier work, which is funny.
Which is kind of cool, though.
Yeah, I was hoping to get to his thesis defense, but I didn't.
That would have been a good.
That'd be a tough gig.
I was so looking for that. We just finished that one. That paper went into PLOS 1, which is an online journal, my first online paper. I'm working now on a gigantic fauna from South Carolina. It's very much like the Georgia stuff. So I've been shipped this big manuscript and lots of bones that are in my lab. I'm going through them, and I'm basically ground truthing a study that two people who were not quite there were doing, and I'm correcting the stuff. And it turns out I discovered 2 of their dinosaur teeth were actually shark teeth.
Whoops.
And fun stuff like that.
Oh, by the way,
yeah. So I'm going through this gigantic collection of 43 plates worth of scrap bones, trying to figure out what they are.
Wow.
And I'm finishing that up right now. And then Dr. Fraser and I have been working on something. Dr. Fraser got in a bad car accident.
Right, sure did.
Now he's back, and we're picking up on that. A study of much older fossils from northwest Georgia, some very strange things, trying to figure out basically what these things are. Little shapely blobs. And we're trying to revise the taxonomy. So that's in the short term.
Okay.
You know, in my kind of field, new stuff pops up. Basically, you see something in the field, you pick it up, you figure out what is it, and if it's important, that becomes the next project.
Wow, that's something new.
So you don't really know where it's going to take you in a couple of years.
So far, every year has turned up something new in the field.
Is that right?
And hopefully that's the way it still works.
Sure.
And so I can't tell you what's going to happen past the next project, but something has always turned up.
Well, what do you find out in the field?
Yeah,
exactly.
I mean, over 34 years of work down here, I probably have 30 different studies I've done.
Sure.
So on the average, one new thing comes up a year.
That's
so
wonderful.
Hopefully as long as it keeps working.
You know what, I'm sorry that we didn't have you bring some slides or some, so we could put something up, because I'd really like to see more. So I was wondering, could we have you back at another time?
Oh, sure,
Bring some
sure.
stuff? Because I'd love to see that stuff and have you talk about that.
Well, I mean, to be honest, the best thing to do to film over my lab where all the good stuff is.
Well, we've got the people that can do it.
I got a whole lab full of good specimens.
Oh, that'd be great.
Yeah,
I think we need to do that.
Sure, come on over. We'll flash some bones and teeth and.
Cool. Let's do that.
And stuff.
Well, I'd just like to say thank you for coming on, and we will get out to your lab because I really want to do that. It was cool.
Great. Yeah.
And I'd like to remind you, you're watching Educational Forum. Thanks for watching. I'm Jeff Conklin.